As anyone who enjoys basketball can tell you, statistics can be a fan's best friend when it comes to understanding a player's strengths and weaknesses. Basketball Reference and ESPN can be helpful for understanding some players, but it can be time-consuming and bland to look up lots of different players, especially role players who don't receive much attention. To make things easier and more fun, we created NBA Player Guesser. We focused on making it easy for basketball fans and stat nerds to understand how players' skill sets are reflected in their stats, which is why we wanted to create a guessing game with a time crunch. In order to get the highest score, users learn patterns in players' stats. Is someone who attempts 7 3-pointers a game more likely to be like Steph Curry or Shaquille O'Neal? Then, to help encourage users to keep learning and playing, we added an element of competition through our leaderboard implementation. This way, users can see how well they're doing compared to others. In order to create an account, all that the user has to do is start on the main page and click the login button in the upper right corner, or they can scroll to the bottom and click on the sign up button below. Once at the login page, users should scroll down to the Create Account section, and they should input an email, a password, as well as a display name which will be used for the purposes of our leaderboard, which is hosted through Google Firebase. Once they click on the sign up button, they will be immediately taken to a new game waiting for them. When a new game is created, the user will have 3 minutes to guess as many NBA players as possible using the stats we present, which were retrieved using the API from balldon'tlie.io. In order to help speed up guessing, we implemented an autocomplete suggestion list, which rapidly searches through the entire roster of NBA players based on what you've already typed in the search bar. All the stats shown on the page are retrieved at once, and each time you get the correct answer, there is a new API request for a new player. If after a certain amount of time, the user is still having difficulty guessing the particular player, they can choose to click the skip button in the upper right at the expense of 4 seconds taken off the timer for each skip. Once time runs out, the user's score and display name are automatically sent to our leaderboard, which is hosted through Google Firebase. If the user is new and has no previous score, it will add their name and score to our backend. Otherwise, if they have played before and already have another score, the backend will only update your public score if your most recent score is greater than your max score. This way, at any given time, each player will only have one result on the leaderboard. To view the leaderboard and compare each user's best score, just click on the leaderboard button in the upper right. If the user wishes to make changes to their account, they should click on the account button in the upper right, where they can update their display name or delete their account if they wish.
One of the things that we had to consider technically was how do we get this game page, all the different components to interact with each other. So what we originally thought of was having this score section, this timer section, and the stat section. These would all be 3 separate different components in React. But when we're trying to implement them all together, we found that it didn't work because the timer affects the score, because once the timer runs out, you're supposed to upload the score to the database in the backend. Also, the skip functionality affects the timer. If you skip, you lose 4 seconds. So that was one of the things that we had to think about in terms of how do we want to correctly implement this. So after trial and error, we found that the best solution was just to combine these different components into one big component. Because they're still all interacting with each other, they're not independent, so we thought that although it made the code a lot longer and the files less clean, it was best to have them in the same React component so that they could talk to each other. Another thing that we had to consider when building this web app was our API that we were using, balldon'tlie.io. This API wasn't as mature or developed as other APIs out there, but it suited our needs, so that's why we decided to go with it. But one of the difficulties is that we couldn't send a bunch of requests one right after the other. Otherwise, it would overload the API and it'd return an error. So we found this when we're trying to break our application by skipping a bunch of times. So if you skip each time, it sends a new request to the API. But if you skip a bunch of times in a row, obviously that would overload the API and would throw us an error. So one of the things that we had to implement was have a 2-second delay on the skip so that we could space out the requests that were being sent after a user pressed the skip button. This also makes sense with our game because we want to give the users a chance in order to guess the player so that they're not just pressing skip until they see someone that they recognize, but they have 2 seconds or so to see if they can recognize the player before they try to skip and guess another player. So one thing, we had a bit more time with this project that we would have implemented, but unfortunately didn't, was within this autocomplete search bar. So when you type in a name, you can hover over and it'll show you which one, and you can click on it and it'll work properly. However, when you have one thing that we wish we had was to use the arrow keys to go up and down and then press enter in order to select rather than having to move the mouse each time to select a player. So if we had more time, we definitely would have implemented that feature just to make things a bit easier for the user, a bit quicker for the guessing process.
When a user wants to create an account on our website, they must put in an email, a password, and a display name. Then they are taken to our game. In the backend, which we're using Firebase, this user's information is stored in Firebase's authentication. Upon the on-click of the Create Account button, we use Firebase's function Create User with Email and Password to store it in this database. Additionally, we have a collection that is hosted by Cloud Firestore, and their email and name are also stored in this collection, as well as their score that they will get on our game. We set the ID of each user to their email for easy retrieval when we need to display their name on our leaderboard. As you can see, initially we had a collection that just stored email and scores, but we quickly realized that we wanted to preserve users' privacy, so we made a new collection that has a third field for users' display name. After a user makes an account, they can log in here. We take an email value and also a password value. And after they click sign in, they are taken to our game. Upon the sign in on click, we use the email and password value and use Firebase's sign in with email and password function to authenticate users. Once users are signed in, we change the state of the current user to be the user that is logged in. This way we can make buttons such as this sign out button, as well as the personalized welcome and the user's name buttons to appear when the users are signed in, and only when a user is signed in. Then they can go into their profile page by clicking welcome, and here they can update their display name. We use Firebase's update function that finds the ID of the document using the email of the current user, which we also set to be the ID of the document. This way we can quickly update the name in this document. By updating the name, it updates immediately in the nav bar, and it also updates in the leaderboard as well. Finally, users can return to the welcome page and delete their account if they choose to. And after deleting their account, they return to the default login page.